everyone, how are you all? I hope you all are doing wonderful. So, as we all know that I have already started a playlist on JEE Main previous year session on different topics of mathematics. So, if you are someone who is basically new to this particular platform, then I would recommend all of you to basically go to the playlist of this particular video in the description, where you will find the JEE Main previous year question session playlist. And in the question session, you can start following from that for this JEE Main previous sessions. I have already covered the chapter of straight lines, circles and parabola, and on that particular note, putting forward, I will be starting with the today's discussion on ellipse, and the upcoming session I will be completing the hyperbola. That's how we're gonna be finishing the entire conic section. So let's start with today's important previous year questions on the topic of ellipse. So if you are someone who are new, then definitely do so, and if you are familiar with the type of questions and how the way I proceed the questions, then I would recommend a point of note is that once you start solving question, whenever you are given a question on your screen, pause the video at that particular moment and start to solve it on your own. Once you get to the answer, tally that particular answer with your answers and definitely comment me down in your comment section. All right, how much marks are you getting out of this particular, like you can consider +4 for the correct one and -1 for the wrong one. All right, that's how you can marking scheme you can follow. So today will be the on the topic of ellipse. So this will be today's goal is to be solving the top 11. Okay, instead of 10 I took 11 problems. All right, because I was thinking that because you all know that JEE Mains also has numerical type of problems as well. To encounter that particular, I also took some numerical problem from the chapter of ellipse. I hope you will be able to understand those. Okay, so if you are have completed the chapter ellipse, then start preparing with now. Let's get started with a pen and a paper. Okay, so the very first problem is a problem which talks about, okay, an ellipse. So it says an ellipse with center. Okay, so the ellipse has a center 1 comma 0. So it is not the very symmetric ellipse. It is saying the ellipse with a center and latus rectum. Okay, so latus rectum is a it's like a chord or a perpendicular chord, okay, which passes through the foci of the ellipse. All right, so latus rectum of length, so it is said there latus rectum as the length, so the length of the latus rectum is basically half. Okay, the latus rectum length is half, have its major axis along the x-axis, and if the minor axis subtends an angle 60° at the foci, okay, then the square of the sum of the length of the sum of the length of the minor and the major axis is or are. Okay, so we have to find for the square of the sum of the length of the major and minor axis. So if you think, let me draw it properly. Okay, so if I use this, okay, so if I draw this particular as a coordinate axis, where it is said that the x-axis is the major axis. So the ellipse will be of some format like this. Okay, with the center 1 comma 0 over here. So the ellipse. So if you represent this particular point, okay, instead of representing this particular point, if you say that this point where this particular point as 1 comma 0, then the ellipse will look like something like this. Okay, with the major axis as the x-axis. Okay, don't go by my diagram. I'm trying to draw it as rough as possible. All right, so okay, I will correct my handwriting. Okay, I'm trying to get better at it. All right, so that's the ellipse. Okay, now it is saying that if you consider the foci, okay, so if you consider the first focus as S1 and the second focus as S2, so it is saying that the if the minor axis subtends 60° angle at the foci, okay, so it is saying that at both of the foci the minor axis basically subtends an angle of, so the minor axis subtends an angle of 60° at both the foci. Okay, so at the both the foci or at both the focus, the minor axis subtends 60° angle. So for any one of the case, you can definitely solve for. Let us firstly use the property of latus rectum of length a. So if I say that this is an ellipse which is basically shifted ellipse with x minus 1 whole square divided by a square plus y square divided by b square is equal to 1. This is the equation of the ellipse with center 1 comma 0. All right. So with the minor axis, length of the minor axis is basically 2a and length of the major axis is basically equal to 2b. That means I am saying that a is greater than b. Okay, because this major axis is along the x-axis. All right. So what you can say from the length of the latest septum, the length of the latest septum is basically given by 2b square by a. Okay. So if you have covered the chapter, I am not going to the derivation of it because it is very simple to derive. Okay. You can definitely do so because the ellipse of the ellipse has a foci at ae comma 0, okay, and minus ae comma 0. But in this case, the x minus 1 coordinate will be ae comma 0. That means you have to shift this foci, okay. So I'm not writing the foci over here, okay, because it is not mentioned about the problem where how to calculate the equation of the ellipse is not given, so you can't directly get the eccentricity. All right, but what you can do to prove for general result, that is take the ellipse as x square by a square plus y square by b square is equal to 1. From there you know the eccentricity formula and you put that eccentricity and then draw this particular perpendicular line that is perpendicular to x-axis and parallel to y-axis, and then see the intersection point of with this ellipse and get to the distance of that particular lattice rectangle. Alright, so that will be basically 2b square by a, and the lattice rectangle length is given by half. Alright, so also you are given with this particular angle as 60 degree. Now if you look at this triangle is very symmetric triangle, because you know that the part of the ellipse which is above, that means I meant to say that the point where the ellipse cut the y-axis in the positive half is same at the point where the ellipse cuts the y-axis in the negative half. That means this is b and this is also b. That means this particular distance. Okay, so it is saying about the angle subtended. That means this distance is equal to this distance. That means the angle subtended will also be equal. That means this total angle is 60 degree. That means the half of the angle will be 30 degree. All right. So from here you can say that this particular triangle. Okay, I can consider this triangle, and this triangle has a length of AE. Okay, has a length AE, and this is B, and this is saying the triangle has angle 30 degree. So from here, if I apply some trigonometric principles or rules, that is tan of 30 degree is basically equal to b by ae. All right, I can write this. All right, so also what I can do, and this is basically equal to, also this particular value is equal to, okay, so let me represent this value as 1 by root 3. Okay, now what I can do, I can from this particular expression I can get to the value of b square as a by 4. Okay, I can get b square as a by 4. And now if I have b square as a by 4, okay, and now if I have b square by a by 4, what I can do, I can square this particular equation. So let us do that in the next page. So what I will do, I will square this particular equation, that is b square by a square e square is basically 1 by 3, and in place of b square I will put the result, that is a by 4. So in place of b square, so also I can do like, I know that a square e square is equal to a square minus b square for an ellipse. Okay, for ellipse this is a true relation. All right, this is how you basically define the equation of an ellipse. Okay, once you are understanding the derivation of the equation of ellipse, you are knowing this particular relation. Okay, so what I can do, I can replace this particular as b square is equal to, or I can write this as 3 times of b square is equal to a square minus b square. All right, and this will give me the relation, that is 4b square is equal to a square. And in place of b square, if I put a by 4, from the previous equation, I will get the value a as either 0 or a as equal to 1. Okay, so but since this is an ellipse which cannot have major length of the major axis is 0, that means that a must be equal to 1. Okay, so a is equal to 1. So this is not possible for an ellipse, so this is possible. Now if a is equal to 1, then b will be equal to 1 by 4. I mean to say b square will be equal to 1 by 4, and this will give me the possibility of b basically equal to 1 by 2. Okay, because length should be positive, so it is b is equal to 1 by 2. Now I have to find for the sum of the square of the length of the major and minor axis. Now there is a point that I will like to say, because many students make mistake over here. Okay, so I will write this as note. Don't make this mistake. Okay, whenever you for solving questions of ellipse or hyperbola, whenever you find for the value of a or b, don't directly write the length of the major axis as a or length of the minor axis as b. All right, so don't do this mistake, because it is the length of the major axis, it means the total length, that is 2a. The total length of the minor axis, that is total length, that is 2b. So that means I have to find for the value of sum of the square of So sum of the square, that is 2a whole square plus 2b whole square. Okay, but it is not what is asked in the question. It is saying the sum of the, okay, square of the sum of the length of the minor and the major axis. So that's also another important thing that the question says about sum of the square of the sum. Okay, so you have to firstly take the sum and then square it. Okay, the square of the sum. So that is basically equal to this particular result, and it is equal to 2 plus 1 by 1 whole square, and that is equal to 9. I hope this answer is clear. So that gives me the right answer, that is basically 9. I hope you have done this particular on your own, and you are coming to this after solving on yourself. All right. So that was a simple problem. Okay. So now let us move forward and solve the second problem. Okay. Now second problem is again a numerical based problem. Okay. So firstly, again, I would say the same thing. Pause the video at this right moment and start solving the problem on yourself. All right. So this problem, I will take this orange color as well. Okay. So it is saying in the problem that there is an ellipse. Okay. So the equation of ellipse is given by the operator equation, that is E, and it is saying that x square by a square plus y square by b square is equal to 1, and it is saying that the line x is equal to 8 is the directrix of the ellipse. Okay, it is the directrix. Okay, directrix of the ellipse. So the x is equal to directrix, that means for the general ellipse with an x axis as the major axis, the directrix of the ellipse is basically given by the two directrix are b by a by e. Okay, sorry, a by e. Okay, so if you have studied the chapter, you must know all these things. Okay, and it is saying that a by e is equal to 8. Okay, so from here I can write that ae, and also it is saying the focus, and also it is talking about the focus. One of the focus is a 2 comma 0. Okay, if this since this ellipse is has a center origin, that means the foci other focus will be minus 2 comma 0 as well. All right, so from here I can also write this as ae is equal to 0, and also I have a by e is equal to, sorry, not 0, oh very sorry, this is equal to 2. All right, and a by e is equal to 8. That means if I multiply both of them, so if I multiply both of them, I will get a square is equal to, so this is 2 into 8, that is 16, and from here I will get the value of a as 4. And if I have a as 4, I can substitute in place of this, I can get e as half. And if I have e as half, I can definitely get the b value, because eccentricity is equal to square root of 1 minus b square by a square. So this will be equal to square root of 1 minus, so b square divided by a square is basically 16. Okay, so and e square, e, that is half, and if you square both the sides, it will be 1 by 4. Okay, 1 by 4, sorry, minus 1 by 4 plus 1 is equal to b square by 16. You take this on the left hand side and this on the right hand side after squaring. So with this it will give you the result, that is b square by 16 is equal to 3 by 4, and if I cancel, their value will be equal to 2 root 3. Okay, so the value of b is equal to 2 root 3. Okay, so I got all the parameters, that is the eccentricity value, the value of the parameter b, and the value of the parameter a. All right, now it is also saying me that if the tangent to the ellipse at point p in the first quadrant passes through the point 0 comma 4 root 3, then and intersect the x-axis at q, then you have to find for 3 times of pq distance whole square, that means 9 pq square. All right, so how will you do so? Now let us draw the ellipse. Okay, so since we have got all the parameters of the ellipse, okay, so the parameter over here, it is basically a value, that is 4 comma 0, and this will be minus 4 comma 0, and this value will be 2 root 3, 0 comma 2 root 3, and this will be 0 comma minus 2 root 3. Okay, that's the ellipse, and we have the focus s1 and the other focus s2. We have the directrix over here, that is x is equal to 8. Okay, and similarly there will be another directrix, that is x is equal to minus 8. Okay, so that's the complete information about the ellipse. So this is x and y axis. Okay, now it is said that any point, okay, at any point p, now we know that the parametric representation of any point on an ellipse is basically given by theta, and that is basically equal to, that basically is similar as a cos theta comma b sin theta. So that's the parametric form, that's the parametric point on an ellipse. That means from this parametric point, if I draw a tangent, so if I draw a tangent, then the tangent will have the equation t is equal to 0. This is the operator notation. So for t is equal to 0, you have to put in place of x square, you have to put x into x1. So that will be giving you the relation x into cos theta divided by a plus y into sin theta divided by b is equal to 1. So that is the equation of the tangent. Now it is saying that the tangent passes through the point. Okay, now this particular tangent pass through point 0 comma 4 root 3. Okay, it says that in the question it passes through 0 comma 4 root 3. So if I put in place of x and y 0 comma 4 root 3, I'll get the relation for x is 0, so this will be 0 plus 4 root 3 sine theta divided by the value of b is basically 2 root 3 and is equal to 1. So from here I'll get sine theta is equal to half. Okay, so I get the value of sine theta as half, and if sine theta is half, that means theta, for theta in the first quadrant, it is equal to 30 degree. Okay, so it is equal to 30 degree. That means I will get the value of point P as a cos theta. That means we will be equal to 4 into cos theta, that is equal to 4 into root 3 by 2. That will give me the point P as 2 root 3 comma, and b sine theta will give me the coordinate root 3. That will be p coordinate is equal to 2 root 3 comma root 3. Okay, and also for q coordinate, q is the point where this tangent intersect the x-axis. That means for this particular tangent, if it intersects the x-axis, okay, intersection of the x-axis, intersect at x-axis. Okay, so for intersection at x-axis, you have to put y is equal to 0. So if you put y is equal to 0, you will get x as, okay, now we have already got the value of theta, so there is root 3 by 2 and into 4 is equal to 1. So from here I get the value of x as root 8 by root 3. So that's the value of the x. Now for q, I will get the relation as 8 by root 3 comma 0. Okay, so I got the value of point P and the q point. Now our task will be to find the value, that is 9pq square. Okay, so what is the value? Now pq is basically the distance between the 2 points. So we know the distance between 2 points, where will be 9 multiplied by the, firstly take the difference. Okay, so if you take the difference, that is 8 by root 3 minus 2 root 3, and for the second one it is plus of 3. So this will be 8 by root 3 minus 2 root 3 whole square plus root 3 whole square, that will be 3, and whole multiplied by 9. So if you perform this relation and calculation on yourself, you will find that this answer is equal to 39. Okay, so the answer to this particular problem will be equal to 39. Okay, so the relation answer is equal to 39. I hope this particular discussion was clear. All right, so with this, I was liking to take more question on the numerical type, but since I have also to take the MCQ question also, so I didn't take many of the questions, but you can definitely try them on your own. I will leave some questions in the description box as well in form of a drive link. Okay, so in the description you will find a Google Drive link where I will leave some questions, okay, some numerical type questions which you need to practice, okay, for your JEE Mains numerical type problem session. I hope you will do so. Okay, and definitely comment me about any doubt you are having, because you know that the once you comment, I am always ready to help you. Okay, I'm always ready to help you, and quickly you will get my help. All right, that quickly you will get my reply. I hope that thing is clear. All right, so with that, let us move to the third problem. And the third problem is again an interesting problem. So as you can see of this now, that till now the numerical problem were very simple. They were mostly formula based. Okay, but now onward you will find some important question as well, okay, which are basically like little bit of theoretical. So for those questions, let me try out this. So this particular problem says that now again for ellipse and hyperbola and parabola as well, the topics of tangent and normal is very important. Even for circle also, the tangent concept of tangent or the equation of tangent is very important. All right, as well as the for circle, I already told you the three important points are chord of contact, chord of contact, the chord with a given midpoint, and a pair of straight line, a pair of tangents. All right, so that's the important thing they must prepare before, like for the conic sections. Okay, like if you ask me like which is the most important thing about conic section, I would say those things. Okay, now let us start this particular problem. It is saying for the ellipse, the ellipse has x square by 36 plus y square by 4 is equal to 1. Now it is saying that the tangent and the normal at point, so at point A, so let me write this point A as 3 root 3 comma 1 on this particular ellipse it is saying that the tangent and the normal meets the y-axis at point A and B respectively. Okay, so let not this be the point A, let it be point B, that will be better. So this is equal to point B. All right, so it is saying that whenever you're taking the tangent and the normal at this particular point on the ellipse, which meets the x-axis at point A and B respectively. Now, C with the circle drawn taking A and B as the diameter and the line x is equal to 2 root 5 intersect the C at point P and Q. Okay. Now, if the tangent at point P and Q on the circle intersect at point alpha comma beta, is then the value of alpha square minus beta square. So there are a lot of things that is the question, the examiner is asking you. Okay. Okay, let me change again from P to some other values, let that be X, okay, because P is also already used in the problem. So let me draw the situation. So whenever you are given a problem on conic section, it is always recommended, if you know the equation of the ellipse, if you can understand the coordinates, then it is always recommended to draw the coordinate, because that will give you a clear pictorial idea. Okay, so let me first draw the, so this is x and y axis. So for this ellipse, okay, so let me write show this ellipse by this. Okay, I'm trying to improve my drawing as well. Okay, so as you can see, this will be 6 comma 0. So since the ellipse equals in x square by 36, and this will be minus 6 comma 0. Similarly, this point will be 0 comma 2. Okay, and this point will be 0 comma minus 2. So that's the ellipse. Now at a point x, so let that point x be over here, that is 3 root 3 comma 1. Okay, now it is saying that the tangent over here, the tangent is something like this, intersect the x-axis at point A. And similarly, the normal, if you draw the normal, okay, so the normal will be perpendicular tangent, and that intersect the x-axis at point B. Okay, and it is saying that if you draw a circle taking A and B as the diameter. So let me clear the drawing. Okay, so as to draw the circle. Okay, so let that be the point x, and by small notation I'm showing it. Okay, so if I draw a circle taking A and B as the, okay, I took A and B as the diameter, okay, endpoints of the diameter, and this particular circle and the line 2 root 5. Okay, so 2 root 5, let the line 2 root 5 is basically less than 6. Obviously it will be less than 6, because root 5 is basically 2.5 something. Okay, or maybe 2 point, I don't know, but it is like more than 2. So 2 into more than 2 is something 4 plus, that will be line over somewhere over here. Okay, so it is like x is equal to 2 root 5, and this particular line intersect the circle at P and Q. And at P and Q, if you draw the tangents, okay, if you draw the tangent at P and Q, then those tangents intersect at point. So those tangents intersect at point alpha comma beta. So to look for alpha and beta value. All right, that's what the diagram has to say. So you can see how complex the diagram looks like. Okay, so this will get very simple once you start solving. Okay, so let us solve. Firstly, let us write the equation of tangent, okay, at a given point, that is x, that is 3 root 3 comma 1. Okay, so I have already the points, and let us me write the equation of tangent. So the equation of tangent is basically x into x1 by a plus y into y1 by b is equal to 1. So that will give me 3 root 3 by a is basically 6 into x plus, and that will be 1 into y divided by 2 is equal to 1. That is the equation of tangent. That will give me root 3 by 2. Okay, root 3 by, oh, sorry, that's a mistake, not a, that is a square, because if you take parameter, then only it will become a, because the a and term and the numerator and the denominator will get cancelled. So this will be 36 only, and this will be 4. So this will be root 3 x by 12 plus y by 4, which is equal to 1. So that is the equation of the tangent. And now for the equation of normal, okay, so the equation of normal at the point 3 root 3 comma 1, using, I will use the slope approach. Okay, I will use basically the point approach, or how to write the straight line, because once you have this equation of the tangent, so this will have the tangent as slope of the tangent, so you can find the slope of the tangent from here. This will be basically root 3 by 12, so take a minus also, divided by 1 by 4, and 1 by 4 it will go up, so this will become minus of 1 by root 3. That means the slope of the normal will have root 3. Okay, so from there you can directly write the equation of, so this will be with a slope of root 3 is equal to y minus of 1. So from here you get the equation of the normal, that will be if you solve this equation of the normal, so if you can solve it on yourself as well. All right, so if you do some calculation, or if you multiply it again by root 3 in both the side, you'll get the equation of the normal as 3x minus root 3 y is equal to 8 root 3. So that's the equation of the normal. Okay, so that's the equation of the normal, and I have already found out the equation of the tangent. Okay, let me clear this line. All right, it's better looking like that only. Okay, so that's how I got the equation of normal and tangent. Now the point B is basically the where the normal intersect the x-axis. That means in place of y you put 0, so that will give you the x value, or you can write directly the value as the value of point B will be like, okay, let me read the question. It is saying that it meets the y-axis. Okay, so in the problem it is saying it meets the y-axis. Okay, it is saying it meets the y-axis. So that means in place of x you put 0, that will become 0 comma 0 comma minus 8. Okay, so that will give me point B as 0 comma minus 8, and similarly for the tangent, the value of a, the coordinate a will be 0 comma, so if in place of x you put 0, so it is 4. So you got to the coordinate as, okay, so you got 0 comma 4 and 1 as 0 comma 8. So you got both the values a and b. Now the equation of circle, now I have already covered this. Okay, equation of circle with with diameter AB, this will become x minus x1 into x minus x2, that is again 0, plus y minus y1, that is 4, and another y1 is basically minus or minus 8, so that will be plus 8, is equal to 0. So from here you will get the equation of circle as x square plus y minus 4 into y plus 8 is equal to 0. Okay, now it is saying that the line, now this circle is divided by the line 2 root 5 in two places, in in P and Q. So let me put x is equal to 2 root 5 in place of x. So from here if you solve, it will be 20 plus y square, and what is the sum of the roots? Okay, you can directly solve. The sum of the root will be, one root is 4 and one root is minus 8, so the sum of the root will be minus of 4, that will be minus of, that is plus of 4y. Okay, and the product of the root is minus 32. All right, and is equal to 0. So from here you get to the equation. The equation you basically get from here is basically y square plus 4y minus 16 is equal to 0, and that will give you, so it is minus of 16. Okay, I guess I have done it correctly. All right, all right. So from here, you will definitely, you can use the quadratic formula for solving this particular, and you will definitely get the value of this y and x also. Okay, you will get the two roots. Okay, so from here you can definitely factorize this as, the factorization of the roots will be like of this fashion. So if you take, so 16 is basically factorized as 8 into 2, and 8 and 2, so 4 into 4 also, and you can also take 16 basically 8 into 2, and so yeah, you can definitely proceed further. So I guess this is not 16, this is 12. Okay, so that's a mistake from my side. That's what I was wondering, what's the error is. Okay, so this is 12, and that will basically 6 into 2, and that is minus of, sorry, plus of 6 into y minus 2 is basically equal to 0, and that will give you the roots as minus 6 and other root as 2. That means that the point P will be basically 2 root 5 comma minus 6, and the point Q will be 2 root 5 comma 2. Okay, now you have to draw tangents at both the point P and Q. Now you again know that how to draw the tangent for the circle. So if you draw, by taking the operator, that is t is equal to 0, you will again find the tangents, that is t1 and t2, and then find for the point of intersection. So I leave this particular part onto yourself. Okay, so you can definitely do that particular rest part, because I have done a lot of things. Okay, so you got the point P and Q. So from there you will firstly find t1, that is tangent at point P. So I represent like this, and tangent at point Q. Now they will intersect at point alpha comma beta. Okay, so they will represent at intersect at point alpha comma beta. Okay, so I have already done this out on my graph. Okay, and I found out that the value of alpha was coming out as 18 by root 5 comma, and the value of beta was coming out as minus of 2. So from here you can definitely put, that is alpha square minus beta square, it will be basically 18 whole square by 5 minus 4. Okay, and that will be equal to, 304, that is 324 minus 20 by 5, that is 304 by 5. So that's the value. So which is at the right answer is basically option number B. All right. So I guess this particular problem was very simple. Okay, but only calculation part is involved. All right. So if you are able to solve this calculation on yourself, if you can manage this simple calculation, then you can definitely ace any difficult problem of JEE Mains. Okay, because JEE Mains problems are not very difficult. They might seem lengthy with difficult values. Okay, what I personally have tackled is that many times the question setter actually tries to play around with the mentality of the student, because the student basically in the examination point of situation, they basically are overwhelmed in the situation that they have to solve lot of problems and definitely get worried about. Okay, so I guess you won't do that. Okay, sorry. All right, so let me move further and let's solve the next problem. So the very next problem, it is saying that now P is basically given as 2 root 3 by root 7 comma 6 by root 7 Q, R and S with the 4 point on the ellipse, and the ellipse has the equation. So the equation of the ellipse, let me write it down in a good fashion, that is x square by 4 plus y square by 9 is equal to 1. So it is a vertical ellipse. Okay, so it is a vertical ellipse, that is the major axis is the y axis. Okay, so the major axis is something like this. All right, so this is the ellipse with the coordinate as 0 comma 3, the endpoints 0 comma minus 3, and this particular point is 0 comma 2, and this point as 0 2 comma 0. Okay, again I do mistake, it is 2 comma 0, and this will be minus 2 comma 0. All right, let me erase it and draw it, write it properly. All right, so that you can also take good notes. But what my intention is not to make good notes. Okay, my intention is to make you solve the problem, like how are you going to solve the problem in the examination point of situation. All right, so that's what my task is. You can make good notes as of your choice. Okay, but the time for making good notes is not not feasible over here, because I don't think that you are left with much time. The only time that is left is basically to prepare, that is to practice and revise, practice and revise. That should be the daily task that a student who is preparing for the JMS examination in the first attempt should have in mind. Okay, so let us solve this particular problem, and it is saying that the ellipse has these particular values, and P and Q and S are mutually perpendicular and they passes through the origin. Okay, they are mutually perpendicular to each other and they definitely pass through origin. So I can consider this as P and Q. So this as P and Q. So P basically in the first quadrant. Okay, so P and Q. Okay, P and Q. So like this, and they passes through origin, and similarly R and S. Okay, R and S passes through origin and they are perpendicular to each other. That's the important thing. All right, so what I can write is that I can take this radial distance. So this is basically known as a radial distance. So the point from the origin is basically radial distance, and let me write that as r1. So I will firstly represent the point o distance OP as r1 distance, and that is basically equal to, that is will be given by square root of 2 root 3 by root 7 whole square. Okay, plus 6 by root 7 whole square. All right, and that value will be equal to, and that particular value will be equal to 12 by 7 plus 36 by 7 under root. So if you sum up, this will be 48 by 7, and that will be, so 48 by 7. So if you take 48, that is 4 into 12, so you can write this 2 root under 12 by 7. All right, so you can write this as, okay, now you got one of the focal distance. Sorry, it's the radial distance of any point. And let me write first, now let me go on and represent the point P as, this was point P something like this, 2 root 3 by 7. Now there is a important trick that you must understand in order to solve this type of problem. That is, you can write this particular point P in a polar coordinate notation. That is, if you have the polar coordinate notation, that is somewhere like r1 cos theta and r1 sine theta. Okay, so you can definitely write this particular point as this polar coordinate notation, and in this polar coordinate notation you are taking the r1 as the radial distance, that is OP. Okay, and if you do so, then the P, and the P also lies on the ellipse, then it must satisfy the equation of the ellipse, and that is, so if you put again this particular value back into the ellipse equation, this will give me a very important relation, and that is r1 square cos square theta by 4 plus sorry, r1 square sine square theta by 9 is equal to 1. All right, so we obtain this particular relation, and we already know the value of r1 square is basically equal to 48 by 7, and that will give me cos square by 4 plus sine square by 9 is equal to 7 by 48. 7 by 48, that's the first equation. So let me write this as a first equation. Now similarly, we are already knowing that that point, if I draw, now what I can say that this OP and OK are perpendicular to each other. Okay, that means this radial distance must be of this particular format. That is, in place of, if this is as theta, so this is the azimuthal angle that I am taking as theta. So if I have to represent the same by this r for this point r, so this particular point of r will have the azimuthal angle that is pi by 2 plus theta. I hope this particular discussion is clear. Now this is a very new concept that I'm trying to establish to all of your brain. Okay, because whenever you will doing question, you are not going to solve the question every time by a very set procedure methods. What instead you can try this particular approach as well. All right. So from here, you in place of theta, you just put that is pi by 2 plus theta. All right, and then you will get the point r as, okay, and then you will get the point of r as basically equal to, so you will get the point r as minus, and that radial distance will be somewhere different, and that is r2. So r2 sine so pi by 2 plus cos theta, that will become sine theta. Okay, minus of sine theta comma r2 and r2 cos theta. All right, so that will be the coordinate of r, and we also know that the line rs is perpendicular to the line pq, then they are perpendicular, that the angle between them is 90 degree. So that's how I basically do this. And now this also will satisfy the equation of the ellipse. So if this satisfies, that is r square r2 square sine square theta by 4 plus r2 square cos square theta by 9 is equal to 1. All right, so from this particular two equation, what I can also do and take this r2 as common and write this over here. If I cancel the r2 over here and I write this as r2 whole square of this particular fashion. Now since these both the values are equal, that is the from first equation, and this is second equation, so I can write this. So from 1 and 2, what I get is basically that I am getting is 1 by r2 square is equal to 1 by 4 plus 1 by 9 minus 7 by 48. 7 by 48. So that's an important thing. Okay, so 1 by 4 plus 1 by 9 minus 7 by 48 is basically the value of 1 by r square, and that is equal to 31 by 144. Okay, I hope you are getting this particular value. Alright, so from here you can also note that the PQ and RS are basically perpendicular and they pass through origin. So what I can write now, since they are passing through origin, and ellipse for this about the origin, it is basically a symmetric coordinate. So if point P has this OP distance is basically R1, then OQ distance is also equal to R1 because it is symmetric about the origin for the case of ellipse. Okay, and similar the condition goes for R and S as well. That means I can write the distance PQ as 2 times of PO, and I can write the distance RS as 2 times of RO. Okay, now what I have to find for the value of 1 by PQ square by plus 1 by RS square, and that will be basically equal to 1 by 2 times of R1 whole square plus 1 by 2 times of r2 whole square. Okay, now you can understand how simple this problem become. Okay, instead of taking different coordinates, instead of writing the coordinates, you basically simplified the question in your respect. Okay, so this is a very important problem. That's what I was talking about, that you are actually learning a different approach. You're actually learning a different approach of solving the problem, and that is equal to, so if you take 1 by 4 common, you will get 1 by r1 square. So r1 square is basically 1 by r1 square. Okay, so R1 was basically equal to 48. R1 square was basically equal to 48 by 7. So that will be 7 by 48. Okay, so that is equal to 7 by 48 plus 1 by r2 square is equal to 31 by 144 and into 1 by 4. So if you solve this, you can solve it. I have done it on my rough. It is basically 13 by 144. So I have to represent this in form of two co-prime numbers, that is such a numbers whose corresponding HCF is basically equal to 1. So those are the numbers. That means P is basically 13 and Q is basically equal to 144. Now I have to find for the sum of the values of P plus Q. So the sum of the value of P plus Q is equal to 144 plus 13 is basically equal to 157. I hope you are able to see this, and with this the answer to this particular problem will be equal to Option number D. I hope you have done this on your own and you have get this particular answer only. Alright, so with this let us move to the next problem, and the next problem is again a very simple problem, but it is an important problem. Okay, so there is a printing error as well. Okay, so let me correct this printing error. So this is not 2 over here, this is actually 12r square. Okay, that's what the question was asking. Now let us find the radius of the largest circle. Okay, it is asking me for the largest circle which is center 2 comma 0 that can be inscribed inside an ellipse which is of the equation. So let me draw the ellipse. Okay, so let me write the equation of the ellipse. Now these types of problems are very common. You can see nowadays many times these types of problems are actually asked in your JEE mains. Okay, now earlier these types of problem were actually asked in JEE advanced. Okay, that's like not in actually this particular problem in advance, but a subpart of this particular problem in advance. Okay, because I remember somewhere because there was a problem on ellipse and inside the ellipse the circle was inscribed, and that was a basically a paragraph type of problem. All right. So okay, so as you can see from here, this particular ellipse will be represented as, so 36 by, okay, so this will be y square by 9. All right, I hope you are getting this. And I have to find the largest circle. So the equation of the circle with the largest radius, that is that, let me the radius of the circle be r, that is the largest, and that will be of the format. So the circle will be of the format x minus 2 whole square plus y whole square is basically equal to r square, and it is saying that it is radius as r, it is already saying in the problem. Then I have to find for the value of 12r square. Now what I can do, I can firstly substitute the y square from the ellipse into the circle equation. Okay, now why I am doing so? Because it is saying that the circle is inscribed in the ellipse. Okay, so the circle is basically inscribed in the ellipse. That means I need to get some kind of a quadratic equation, and what my point of thought is basically, so I will go on saying, okay, let me solve what. So what I'm doing, I'm taking y square from here. The y square value will be 1 minus x square by 36 into 9. Okay, so 9 into 1 minus x square by 36. And if I take the value of y, it is basically square root of, so 3 square root of 1 minus x square by 36. So that's the value of the y. And from here, if I get the y, if I fetch in this particular value of y in the circle equation, because the circle is basically inscribed inside the ellipse. Okay, it is inscribed on the ellipse. Okay, it is basically inscribed on the ellipse. Okay, so it is basically inscribed. So for inscribed condition, that means basically this particular circle and the line basically lies on each other. For the roots of the, then if I put this y value over here or y square over here, I'll get a quadratic in x, and that particular quadratic equation to become a real equation, that means they inscribed on each other. Then for becoming a real condition, then they must represent the condition of real intersection point. Okay, that means they have a real intersection point in common because the circle is inscribed inside the ellipse, and that will basically ensure that the discriminant of this particular quadratic of the quadratic that I'm going to make. So the quadratic that will be x square minus 4x plus 4 plus plus 9 minus x square by 4 is equal to r square. Now for this particular quadratic equation, it will have the discriminant value is equal to 0. That means they will have real roots. So what I was talking of, actually real roots. And if I have these real roots, then I can definitely solve the value of the discriminant. The discriminant value is basically equal to b square minus 4ac, and for this I'll get it as minus 16 whole square. So you can definitely do the calculation. I am doing it on my own, because if you write this quadratic, the quadratic equation will be looking like it will be 3x square minus, so yeah, it is 4 minus 1, so 3x square minus, okay, minus of 16x, okay, 16x plus 52 minus 4r square is equal to 0. So that's a quadratic. So from here the discriminant value will be again minus of 4 into a is basically 3 into 52 minus r square. So this is minus of r square, and that is basically is equal to, so if you evaluate this expression, this is equal to 256 minus 12 times of, so minus 12 times of 52 minus 52, and directly I'm multiplying it. Okay, and directly multiply, so minus of minus will again become plus, and that will be equal to plus of 48 r square. So plus of 48 r square. So from here if you solve for, now I have to get to the condition for getting the radius of the largest circle. So for the radius of the largest circle that is inscribed, so this particular value what I'm solving is basically there is an ellipse. Okay, so if you consider the ellipse like this, and there is a circle like this. Okay, but this circle is basically inscribed in, that means such an ellipse for such circle which is basically inscribed, that means this particular circle will be like this particular fashion. Okay, I'm not knowing about it, but what I'm solving is basically the condition of intersection of the circle and the ellipse. That is the first thing. But when I'm talking about what the real root, this will be discriminant is greater than or equal to 0. And when the discriminant is equal to 0, that is giving the condition when the radius value is the minimum value, and that minimum value will ensure that the largest circle is inscribed inside the ellipse. I hope this particular thing is clear. Okay, try to understand. When I'm putting d is equal to 0, that will ensure the condition of r is basically less, this is a minimum value. Okay, but that minimum value will ensure me that that is the largest circle that is inscribed inside the ellipse. Okay, that is inscribed inside the ellipse. That means I have to solve for the condition of discriminant equal to 0. Okay, for maximum radius of inscribed circle. Okay, for maximum radius of inscribed circle. Now this is a very important thing that I am talking of. Okay, so many times you will face these types of problems, and definitely don't make mistakes when you are basically solving the problems of this particular type. Okay, so definitely remember that how to solve this particular problems. Okay, that you have to put just discriminant value is equal to 0. All right, so if you put the discriminant value and solve for it, you will basically get the relation as 48 r squared is equal to, so if you evaluate this, okay, you can definitely evaluate, that is 520 plus 104. 520 plus 104 is basically 520 plus 104 basically 654. So 654 minus 256 is basically equal to 368. Okay, 368. And from here you will get the value of r square is basically 368 by 48, and if you can solve it, you will get it as 23 by 3. Okay, 23 by 3, and I have to solve for 12 r square. 12 r square, so I have to multiply again by 12, so that is basically 4 into 23, and that will give 12, and this is 92. So the right answer to this particular problem is basically option number B, and that is option number B. Okay, option number B. I hope you have solved this particular problem on yourself and got the right answer. If you were not able to solve this particular problem, because this is a theoretical problem with a concept involved, this particular concept, okay, this concept is involved, so this particular problem makes it an important problem. I hope you can able to solve this type of problem the next time you face in the examination. All right, so let me move to the next. All right, so let's get started with the next problem. And the next problem says that if there are ellipses for the parameter k, and the ellipses are given as kx square plus k square y square is equal to 1, and the k is basically a parameter value that is changing from 1 to 20. So for every values of k, we get different ellipses. And it is saying that ck with a circle which touches the four chords joining the endpoint, one on the minor axis and another on the major axis. So you get basically one on the major axis and one on the minor axis, and that's how we basically form four chords. Okay, so let me show that by the diagram. So this will be basically clear when I draw the diagram. So let me first draw the diagram of the ellipse. All right, so if you take this as the ellipse, that is x square plus y square, so let me take that the ellipse as the major axis as the x axis. So this will be the ellipse, and what is the four chords that the question is talking about are these. One is the major axis endpoint and other is the minor axis endpoint. So this way you get basically four possible chords. Now it is saying that there is a circle which touches the four chords joining the endpoints, four chords joining the endpoint of the ellipse. So there is a circle, okay, which basically touches this particular four chords. Okay, circle which touches this particular four chord. That means for this circle, these four chords are basically tangent to each other. So I don't go by my diagram much. Okay, I'm trying to make good diagrams from now onwards. Okay, but all right, so if I draw this particular circle in the fashion, okay, so let me draw the circle over here. So the circle will be like this, and this particular chord which is has the endpoint as, so for this first endpoint, that is 1 by k, this is 1 by k comma 0, and for the endpoint of the minor axis will be 1 by k square, 0 comma 1 by k square. So and for this particular circle, so for this circle will be the kth circle, the circle k ck, and for the circle ck I can write the radius as rk, because it is saying that the rk is the radius, rk is the radius of circle ck. Okay, now I have to find the basically rk. So what you can apply that from the origin, because this ellipse is basically centered at origin and it's in the circle which touches the forechord, will obviously will have the center point as origin. So just have to take the perpendicular distance of 0 comma 0 from this particular straight line, and if you look at this particular straight line, this particular straight line will have the equation. So let me firstly form the equation of the straight line. So the equation of this particular straight line, let me write that as a and b. That will be x by 1 by root k 1 by k plus y by 1 by k square is equal to 1. So that will give you the result that kx plus k square y is equal to 1. That's the equation of the straight line. Oh, very sorry, very sorry. This will be not k square, this will be root k. Sorry, this will be root k and there is k. Okay, so that's a mistake, okay, from my side. I'm sorry for that. So this will be root k, this will be root k. Okay, so this will be again root k and this will be only k. Okay, so this will give you the equation of the just one of the chords, and from this particular chord, if you look for the rk, that is a perpendicular distance from 0 comma 0, that will give you 0 plus 0 minus of 1 divided by root k whole square plus k whole square, and then take the square root of this. Okay, so this will give you the result that is 1 by k plus k square whole under root. Okay, because square root is always a positive answer, so if you take the mod, it will be 1 by root under k plus k square. Now what I am supposed to find out is basically 1 by k rk whole square. So if you take 1 by rk, this will be square root of k plus k square, and if you take whole square of that, that will become k plus k square. Now the students who are asking me to solve the chapter of sequence series, this is a question that basically involves ellipse as well as sequence series, because in the problem, after all, you're basically are looking to find out the summation. Okay, you have to find out the summation where k is basically 1 to 20 1 by rk square. So that's how beautifully the question was set. Okay, and this will be equal to sigma k plus sigma k square for k belonging to 1 to 20 1 to 20, and if k for sigma k for k belonging to 1 to 20, this will become equal to k into k plus 1 by 2 plus this will become k into k plus 1 into 2k plus 1 by 6. I hope if you have studied the chapter of sequence series, you know this. Okay, so this will become answer is equal to 20 into 21 by 2 plus 20 into 21 into 41 divided by 6, and that will give you the result. So this result will be equal to 210 plus, and this result will be equal to, so you can cancel out, this will be 2, this is 7, this is again equal to 10, so this is equal to 17, so this is equal to 2870. So 2870, and if you add them, this will be basically 3080, and that's the required answer. So with this, you get the right answer to this particular problem as option number 2080, that is option number D. So I hope you have solved this particular problem on yourself and you have got the answer. So this is a pretty simple problem. Okay, this problem looked difficult at first, but this is a simple problem. Okay, so you must not be afraid of solving this type of problem. Now let us move further and solve another important problem about the concept of common tangents. Okay, now it is saying that there is a circle which is of radius 4, and this circle is basically concentric. Okay, what is this word concentric means? This word concentric implies that the circle and the ellipse, that is, the circle is concentric to something, the something will have the same center as the circle. Okay, and what is the equation of the ellipse? So if you look at the equation of the ellipse, okay, so if you look at the equation of the ellipse is x square by, so 285 divided by 15 is basically 19. Okay, uh, sorry, it is 19. Okay, it is 19 times plus y square, and 19 into 15 is basically 285, so it is really 15 y square by 15. So that's the equation of the ellipse. Okay, so you have the equation of the ellipse like this fashion. Let me correctly write the ellipse. Okay, otherwise it wasn't visible like that. Okay, so the equation of the ellipse is something like this, and there is the center of the ellipse is basically the center of the circle, and that is the center of the circle is also equal to 0 comma 0, that is the center of the ellipse, that is 0 comma 0, and the circle has the radius, and the radius of the circle is basically equal to 4. Okay, so if the circle has a center 0 comma 0 and the radius of the circle is equal to 4, then I can write the equation of circle as x square plus y square is equal to 16. That's the required circle. That's the recursive circle that is talking the problem. And now it is saying that the equation of the common tangent that are inclined to the minor axis of the ellipse is basically at angle. That means you have to find for the tangent which is inclined to the minor axis. Okay, so let me first try to understand what this question is trying to say. Okay, because I am already saying you that in problems of coordinate geometry, when you are not able to understand what to solve in the problem, you basically do it by diagram. Okay, so try to draw the diagram. So the diagram will be like this. Okay, so for the ellipse, the diagram is something like that, and it is basically saying me that there is a circle inside it. Okay, the circle is something inside it, and I have to look for the common tangent. Okay, So how are you going to basically find the common tangent? Okay, because the circle is basically then the common tangent which is inclined to the minor axis. Okay, so there is a trick that you basically need to imply over here. So for the common tangent, okay, it is basically asking for the common tangent. How are you going to do the tangent? Okay, so then the common tangents, okay, then the common tangents are inclined to the minor axis of the ellipse is basically at an angle. Okay, all right, I think there is not no error, all right. So okay, let me write the equation of the tangent. Okay, let me write the equation of tangent for ellipse. Okay, so for ellipse the equation of tangent will be of fashion y is equal to mx plus not minus. Okay, or already you can write also plus minus root under a square m square plus b square. Okay, that's the equation of the tangent for the ellipse, and this will be basically equal to y, or you can write this as mx minus y, mx minus y plus minus root under 19 m square. Oh, very sorry. Okay, the diagram was not very clear. I okay, because the value of a is basically root 19, na. So root 19 is basically somewhere around like greater than 4. So root 19 is basically greater than 4, and root 15 is basically less than 4. So the circle will be somewhere like this. Okay, so that's a mistake. Okay, I say that because people do generally make mistakes in taking a square and taking the value of a. So that must be very careful of. Okay, so it is saying that that common tangent. Okay, so you can see this is a common tangent like this, and it is saying that it is inclined to the minor axis. So what is the minor axis? The y-axis. So it is inclined to the y-axis at what angle? So that's what the question is asking me. So from here I'll get to the equation of the tangent as 19 m square plus 15. Okay, is equal to 0. Okay, and also what I can know that the perpendicular distance from point 0 comma 0 to the tangent or the common tangent is equal to the radius, that is equal to 4 units. And from here if I put the perpendicular distance, that will be basically equal to 19 m square plus 15 root under, and there will be plus minus sign because before that there is a 0, divided by m square plus 1, m square plus 1 square root, and that is equal to 4. So from here if I solve, this value will be equal to 19 m square plus 15 divided by m square plus 1 is basically equal to 16 because I take the square of both the sides. And if you solve this, this will be 16 m square plus 16 is equal to 19 m square plus 15, and in this case this will be 3 m square which is equal to 1, and from here I will get the value of m as root 3. Okay, or to be precise, it will be plus minus root 3 because there will be two possible common tangents that are possible. One is a tangent like this and second is a tangent like this. Okay, so there are two possible common tangents, and if I have the value of slope of the slope of the tangent is basically 1 by root 3, so this will imply that the value of the tangent, that the tangent is inclined with the angle that is tan theta is equal to 1 by root 3, and that will give me the angle, that one of the angle will be basically equal to 30 degree and other one is basically 150 degree. But in the problem it is asking me for the uh, angle, because answers basically show me the acute angle, so that is basically pi by 6. Okay, so 30 degrees basically pi by 6, and that is sorry, all right. Okay, it is asking me that is inclined to the minor axis. Okay, minor axis basically the y axis. Okay, in with the x axis it is basically making 30-degree angle. Okay, so with x axis it is making 30 degree. Okay, I guess it is clear. Okay, or let me write again. So with x axis it is 30 degree. So with y axis it is basically, because they're perpendicular, so with the y axis it will make 60 degree, and that will be basically pi by 3. Okay, so that is pi by 3, and with this makes the answer to this particular problem as option number B. Many students will make mistake by choosing option number C, but that is wrong. Okay, how that is wrong? Because the angle with the minor axis is basically pi by 6, but not with the minor axis. But in the question it is asking me for the angle with the minor axis, and that will make the option number B as the right answer. I hope this particular thing was clear. All right, so with this let us move to the next problem, and the next problem is again a very important problem because people definitely go on seeing the problem and definitely leave the problem by seeing that there is a big problem. Okay, but you don't need to leave this particular problem. It is saying that there is an ellipse that is x square by 9 plus y square by 1 is basically 1. That's the equation of the ellipse, and this ellipse intersect the positive x and y axis at point A and B. So let me draw the ellipse. Okay, so let me draw the ellipse. So let me draw the ellipse, and the ellipse will be basically like this. Over here, -3. So it is saying that it intersects the x-axis and the y-axis at point A and B. Okay, so this is point A. The positive x-axis at point A, that is 3, 0, and the positive y-axis at point B, that is 0, 1. Okay, 0, 1. So that's the point A and B. And it is saying that the major axis of the ellipse with the diameter of a circle. So if there is a circle which is drawn with the major axis of the ellipse, that's also the diameter circle of the ellipse. Okay, with the diameter of the circle, then let the line passing through A, then the line passing through A and B meet the circle at point P. And if the area of the triangle with vertices A, P and origin O is m by n, then what are the values of m and n? For m and n are co-prime numbers. So I can draw a circle. Considering it passes through A and B, that is taking A and the other point, okay, of the ellipse as the diameter point. Okay, so you can do like this, and it is saying that the line through A and B, okay, the line through A and B, okay, line through A and B basically intersect the circle at point P, and I have to look for the area of the triangle, that is AP and origin. Okay, AP and origin. So you can look, this is a triangle. Okay, so if you look at the triangle will be of this particular fashion. So the area enclosed into that triangle is of like this. Okay, so this is the required area of the triangle. Okay, that I'm talking of. So this is the circle. Okay, this is a circle and this is the ellipse, and this is value, this is the ellipse. So okay, all right, so this is the ellipse and the circle. So let me first write the, so what I was going to look for is basically firstly write the equation of AB. So equation of AB, so you can see A and B equation will be x by 4 plus y by 1 is equal to 1, and from here I can write the equation of EB as x plus 4y minus 1, uh, sorry, x by 3. Okay, x by 3. So x plus 3y minus 3 is equal to 0. So that is the equation of the line AB. So let me represent this by equation number 1. Now the point of intersection with the circle. Now circle equation will be equation of circle, because the circle has the radius of circle will be equal to 3. So the equation of circle will be x square plus y square is equal to 9. And if the line AB intersects the circle, then basically if I put x is equal to 3 minus 3y, okay, I can put like this. Okay, I can put x is equal to 3 minus 3y, then I will get it as 9 minus 1 plus y square minus 2y, okay, plus y square is equal to 9, and from here is equal to 9. Okay, so from here 9 and 9 get cancelled, and this will be equal to y square, 2y square is equal to 2y. So from here I get the value of y as, so I get value 1 of the y as, I hope I did this correct. Okay, I took this, so you can see over here, and this is equal to 9, and that will make it as, oh, all right, that's a mistake, okay, that is 2 into 9. Okay, 2 into 9 into y, that will make it. So if I cancel 2 and 2, so the one value of the y is 0, another value of the y possible is basically 9 by, so let me again check it. Okay, so y square, so okay, y square is basically, that is 10y square. Okay, 10y square, not this one, so that is wrong. So this will be give me one of the y value is 0, and other the value is 9 by, so the other value will be 9 by 5. Okay, 9 by 5, yeah. So that's the two values of x coordinate. Okay, that means the point P is not equal to 0. That means point P is basically equal to, the point P is equal to 9 by 5. So with the y coordinate 9 by 5, the x coordinate will become equal to, so you can definitely find the point P as with the x coordinate. Okay, what is the x coordinate of point P? The x coordinate of point P is equal to 9 minus 81 by 25. So from here this will be equal to 225 minus 81 by 25. But I don't need this, because in the problem I have to find for the area of the triangle A, P and O. So this will form the height of the triangle. Okay, so from here you can see the y coordinate will form the height of the triangle, and the x coordinate will form the base of the triangle. Okay, I do need it. Okay, that means I do need it. The base of the triangle, sorry, the base of the triangle we will not, this one is the base of the triangle, what I am doing. So this is not the base of the triangle. The base of the triangle is it. So I don't need the x coordinate. Okay, I don't need the x coordinate. So from here I can directly write the area of triangle POA is half into base into height. The base is 3 and height is basically 9 by 5. So from here I will get the answer as 27 by 10, and that is basically equal to m by n, but m and n are co-prime. That means the HCF is equal to 1. So from here I will get m as 27, n as equal to 10. Okay, and I have to find for m minus n is equal to 17. So that is the required answer, that is equal to 17. So I can see that that is option number C. Okay, so you can mark option number C as the right answer. I hope you have done you are able to solve this particular problem. This is a pretty simple problem, but people do generally tend to ignore this type of problems, okay, because seeing the length of the problem, but that's a pretty simple problem. All right, so you can definitely expect this type of problem in an examination. Now there is another interesting question that I would like all of you to try out on your own. So I would like to give this particular problem as a homework problem. Okay, why I'm giving this particular problem as a homework problem? Because this problem involves a question of not of an ellipse but more of a question of set. So as you can see, in a group of 100%, 75% people, 75 people speak English, 40 people speak Hindi, and each people speak at least one of the two languages. Okay, so it is saying that each of the people will at least speak one or the two languages. That means that there is the A union B the complementary of A union B is basically 0. Okay, that's what basically the question needs to say. Okay, so you can form this by the set of the set value like these values. Okay, so the person speaking A Hindi or English is basically A, and person speaking Hindi is basically B, and the intersecting value will be somewhere around. Okay, so this particular value is equal to this whole value is 75 and this whole value is 40. So that this particular value is equal to 100 minus, sorry, minus 100, that is 75 plus 40 minus 100, and that will be equal to how much? This is basically 115, and this is equal to 15. All right, so this is equal to 15. So from here you can say that is the number of person who speaks English is basically alpha. So the number of person who speak English basically 75 minus 15 only English, and that is equal to 50. Okay, and similarly the number of person speaking only Hindi is beta, that is equal to 40 minus 15, that is 25. Okay, so from here you can definitely say that the ellipse, so the eccentricity of the ellipse is 25 times of beta square. So 25 times of beta square x square plus alpha square y square is equal to alpha square beta square. And if you divide by alpha square beta square, the equation of the ellipse will become x square plus alpha square divided by y square by beta square is equal to 1 by 25. Okay, so that will become, and if you put in place of alpha and beta, if you put the required value, also you can definitely find the eccentricity value as. Okay, so I directly solve this. Okay, you just need to solve it. Okay, so I'm leaving you, this is the eccentricity is basically 1 minus b square by a square. So as you can see, this is a very pretty simple problem. Okay, yes, these types of problems are also possible in your examination. All right, so the answer to this particular problem, I'm writing it as, okay, so since I've done the problem as a whole, so you can ignore this as a homework problem as well. But what my idea was to basically give you a hint, but instead of giving hint, it says the problem is very simple. So that's the option number C. If you solve this, you will find option number C is the right answer to this particular problem. I hope this particular problem is simple and easy. But yes, these types of problems are also possible in your JEE Mains examination. Okay, that's only why I took this. I took this problem just to revise the concept of eccentricity, as well as this there was concept of set involved in the problem. Okay, that's why I took this particular problem. Okay, so with this, let us move to the another important problem, and the next important problem is basically the maximum distance of the normal. So again, it is a problem, it is saying me, okay, so there is a problem which basically talks about, so let me write the equation of the ellipse. The equation of the ellipse is x square by 4 plus y square by b square is equal to 1. Now it is saying that the maximum distance of the normal to the ellipse such that b is less than 2 from the origin. Okay, the maximum distance of the normal from the origin is basically equal to 1, and then you have to find for the eccentricity of the ellipse. So what you know that the equation of normal for the ellipse with a given parameter theta, okay, for ellipse, so it is basically equal to ax sec theta minus by cosec theta. Okay, cosec theta, or you can write ax by sin theta minus by cos theta. Sorry, ax by cos theta minus by sin theta is equal to a square minus b square, that is 4 minus b square. Okay, so that's the equation of the normal for the ellipse. And if I have to find the distance of 0 comma 0 from the normal you will find this particular perpendicular distance. Okay, so you can definitely solve this perpendicular distance, and this distance will be equal to since it is 0 from 0, so x is 0 and y is 0, so this will become 4 minus b square divided by square root of a square, okay, a square sec square theta plus b square cos sec square theta. okay, and a square value is basically equal to 4, and this is the distance, that is the distance d. Now I have to find the, so if you say the distance d is basically equal to 4 minus b square divided by, so 4 minus b square divided by, okay, 4 sec square plus b square cos sec square, okay, and then take the whole square root, that is the value of the d. Now this particular value I have to maximize, I have to minimize, maximum the distance, okay. That means for maximum d, okay, d is maximum when, because it is also maintained in the problem, that is b is basically less than 2, that means you have no condition for other than b less than 2, okay. But what you can do in you have to basically maximize or minimize the theta part. That means for d is maximum, you have to basically minimize the denominator, that is when 4 sec square theta plus b square cos sec square theta is minimum. This is possible when this value is minimum, this particular value is minimum, okay. This is a parametric in theta, okay. So how to minimize this particular thing? You have already studied that a cos theta plus b sin theta is maximum minimum condition basically occurs, and maximum and the minimum value is equal to plus minus root under a square plus b square, okay. A similar thing I will apply, and if you can do this, that is basically actually found out by taking the ratio of this both the terms, and that is basically equal to tan theta, so tan square theta. And if you take the ratio of the both the terms, and that is basically b by 2, okay, that is tan square theta is basically equal to b by 2. So it is basically minimum when this particular relation occurs, that is, and the maximum value or the minimum and the maximum value basically equals to, so this will be equal to 4 minus b square. Also you can do this particular problem by assuming as a function of theta, and then apply the maximum minima, that is differentiate this particular function and equal to 0 to get the critical point, and then take the second derivative and ensure that it is the, that is giving the positive result, that means ensuring there is a minimum result. You can do that on yourself, but since I know some results, I know some results of a sec square theta plus b square cos sec square theta is maximum minimum at what places, I can definitely solve this particular problem. All right, so this problem is basically then the minimum value is equal to, is basically minimum and is equal to root under, so in place of tan square theta and sec square theta is basically related, that is sec square theta minus tan square theta is basically equal to 1. So from here I can definitely write this as, so tan square theta plus 1 is equal to sec square theta, that is b plus 2 by 2, and plus b square, and in place of cos sec square I can write this as, I will definitely write this as b by 2 by b, okay. For that, for completing the right angle triangle, by completing the right angle triangle I can do this, and this particular value if you solve it is equal to 1, okay. So you can cancel this value, this is b in b square plus 2b, and this will be equal to 2b plus plus of 4, okay, and is equal to um, yeah, this particular results hold true when it is equal to 1. Yeah, that's what I'm speaking of. Yeah, and from here you will get the relation, from here you will get the relation, that is 4 minus b square is equal to, because you have to look for the, because it is said in the problem, yes, it is said in the problem, the minimum distance, the maximum distance is equal to 1, the maximum distance is equal to 1. So I put the maximum distance as equal to 1, and now I have to solve for the value of b. So from here I will get the relation as b plus 2, and this is a quadratic equation in b, and this will give you b square plus b minus of 2, minus of 2 is equal to 0. So from here I get the two values of b as minus 1, minus 2 and 1, minus 2 and 1, okay. So I get two values of b, okay, that is one is minus 2 and other is 1. But since b is basically less than 2, okay, b is less than 2, that is b is basically and should be positive, because we know that for an ellipse b should be positive, and it is less than 2, that means for with satisfying these two conditions the b value is equal to 1, because b is again a length na, so it cannot never be negative, right, because I am talking of b. So what is b basically representing? B is basically representing a length. All right, so with this you will get that, or if you take, okay, so with this you will get, and then you have to find for the eccentricity. And what is the formula for eccentricity? It is basically square root of 1 minus b square by a square, and that will give you 1 minus 1 by 4 square root, and this will be equal to root 3 by 2, and with this the right answer to the particular problem will be equal to option number D. I hope this particular problem was clear. Alright, so this is again a pretty simple problem as you can see, but this involves a concept of maximum minima, which is basically you can use the problem to solve this by the calculus approach as well. All right. So with this, let us move to the last problem, and the last problem is again a very important set of problems, which is basically asking the problem questions. I will try to I will give a hint, but I like to like you to solve this particular problem and definitely come up with the answer in the comment section. Okay, because it's a very important type of problem, and that these type of problems are actually asked. Like how to solve this, I will give you some like hint. So for the ellipse, so what you can see, the ellipse is basically x square by 5 by 2 plus y square by 5 by 3 is equal to 1. Now this is saying that the acute angle between the pair of tangents which are drawn from the point. So if you see the ellipse, okay, so if you can see the ellipse, it is basically there are a point 1 comma 3. So from that particular point a pair of tangents are drawn. So if you look this as a pair of tangent, so you have to look for the acute angle between the pair of tangents, that is this angle. How can you do so? Now I would recommend you to write the equation of the ellipse, that equation of the tangent, that is mx plus minus root under a square m square plus b square. Now if you convert this and put the value of 1 comma 3, if you fed 1 comma 3 into this particular value, you will get a quadratic, and this quadratic will give you the hint which I have already covered in the chapter of circle, like how to solve the question when there is a quadratic in m square. And what m represent? M represent the slope of the tangents, two tangents that is possible. I hope I have given a lot of hint for solving this particular problem, and then you can definitely apply the formula for like solving the angle between two straight lines, that is tan theta is basically m2 minus m1 divided by 1 plus m2 m1. Okay, and take the modulus because you have to take for the acute angle. So you can apply this formula and definitely get it. So from here you get the roots as m1 and m2 by satisfying 1 comma 3. With this you will get a quadratic equation, and that will give you the hint. Like you don't need to actually solve the equation, but what is basically thing is the sum of the roots and the product of the roots. That concept you can use and definitely get to the answer. I'm leaving the solution for you to solve it and come out the answer. Okay, I am waiting for your comments. All right, so with this I come to the end, and that's where all my questions that I was taking on the chapter of ellipse. Okay, so that was my take for the important problems on ellipse. So ellipse is a very important chapter. Okay, if you have covered it, then you can definitely ace the problems with easy. Okay, with easy peasy. Okay, these are very simple problems. Okay, so if you have studied the chapter, you can definitely solve questions. Again, I'm saying the important topics are tangents, normals, okay, and those important properties of an ellipse. Those important properties, if you keep in mind, you can definitely solve any problem of JEE Mains level, all right, for the chapter of ellipse. And that was my take on ellipse, and thank you.